And hello, this is Michael Booker. You are watching the video for The Way of Reason, and we're going to be doing Chapter 6 information today. In the first 5 chapters of the book, we've been working with informal logic. We've been working with a lot of logical fallacies and different things related to good decision-making processes. Hopefully by now you've finished not only the first 5 chapters, but you've also done the Internet Research Project, which is about critical analysis of sources. And you've also done the SquidMat project, which is a decision matrix program. The point to all of that is to learn about building information in an informal manner, but to do it as well as possible. The last 3 chapters of the book change the tone of this material rather seriously. We're going into formal logic. And if you've been paging through this material, it can be hard to follow, which is why, and exactly why, what we've done right now is we've gone to this. We're going to show you some videos. And there's going to be a total of 5 video segments. Chapter 6 will have its own segment. There will be a segment on Chapter 7a related to long truth tables. I'll then show you how to do short truth tables for Chapter 7b. And then Chapter 8 will be broken into 2 parts with logical equivalences and logical inferences. So this is all material that you're going to need. I would suggest you try using this video. If this is not working exactly for you the first time you watch it again. And there are also other videos posted to the website from earlier versions of these presentations. I keep trying to refine the process so it will be as good as possible. You're going to see my hands in here. You're not going to see my face. Nobody really needs to look at me if you want to see what I look like. There's a cartoon in here, or else go to the office. And there you go. That's me. Okay. So what's symbolic logic? There used to be an old method of logical reasoning that was developed by Aristotle. And as I told you in this book, really all of this comes out of Aristotle in at least its earliest forms. But Aristotle said that there's only a finite number of ways to make a statement, and he had 4 of them. The format that he used was constricting and unnatural in a lot of ways. And so around the middle of the 19th century, that is to say the 1800s, we saw the development of new forms of logical notation, and the one we're using right now is about 150 years old. If you're wondering, and this is always a fair question, if you're wondering what difference this stuff makes, what utility it might have, this material is the way that we've decided to build our computers. When we came to computers, we had the interesting ability to process on and off signals, and the way that we process them is through something in electronics called logic gates. At the end of Chapter 6, I even show you some notation, not a physical image of a logic gate, which would be a microscopic thing anymore, but just showing you, not that you have to memorize this, but showing you that the things that we're doing now tie very strongly into the way that we make our machines work. And so there is a wonderful value to this thing that was originally created just as an attempt to reason well, and really without any practical implications beyond that. The basic unit of measure for this material that we're going to see in Chapter 6, which is here, The Way of the Firefly, and if you've got a good enough image where you can see page numbers, this may be different from the book you have. Right now, as we film this, I'm using version 2.2 of the textbook. Some of the page numbers are going to change, so I'll try not to reference those. The content's not going to drastically change. But as it explains right off at the bat here, there is a core unit to what we do in Chapter 6, and this is just called a proposition. A proposition is just any statement that can be true or false. And whether it's true or false might vary depending on when you make the statement. If I say it's snowing, most times you say that statement, it would be false. But realistically, if you're bothering to say it, you're probably saying something that's true. Is every sentence that you utter a proposition? Well, certainly not. If you ask a question, if I ask, what time is it? That can't be true or false. I can't be true in asking what time it is. I cannot lie by saying what time is it. I'm asking a question. I suppose I could be a little tricky because I already know the answer or something, but ultimately it's just a question. If I give you an order, like run, that also would not be a proposition. a proposition has to be true or false. To add maximum flexibility to the system we're looking at, I'm using a Sharpie, so I'm trying not to bleed through everything. We just use letters, A, B, C, D. Most of the time, if you read logical material, it's P, Q, P, Q, and R. And what these letters stand for is whatever we say they stand for. So A is a proposition. And what? An apple is a fruit. Might be what the letter A stands for, but I would have to tell you that that's what the A stands for. Only in Chapter 6 are we even going to play around a little bit with what these letters might stand for. After that, we're going to simply be looking at the formal structure of ideas. And as it turns out in logic, the formal structure of the ideas is independent of their content. That is to say, once we get to Chapter 7 and 8, it won't matter what the letter A stands for. There is a process we're going to do briefly in 6, though, that would show you how to transfer something into one of these other formats. So we start off with a letter, and the letter might be true or false. Again, I don't necessarily know the answer to anything I might make as a proposition. What we do with these propositions is we say, though, that they have to be true or false. And so if P stands for the Pope is Catholic, I would sincerely hope that that's a minimum job requirement, and I would presume that that is in fact true. But we could, imagine the Pope gets replaced by a robot, and then the Pope wouldn't be Catholic. He would be a robot who prays to the robot god or something. Who knows? This letter P can be either true or false. And what we're going to do with these letters is we're going to connect them together. This is what the machines do, and this is what, at electronic level, logic is doing. Now, I've tried to represent this a couple of ways in the book. You're going to see tables. We'll do a lot with tables in Chapter 7. I even have this little icon with the fireflies trying to graphically represent what they stand for. We're going to be working with a total of 4 symbols in all of this. Actually, there's a 5th one we'll pick up later. So if I say that P is the Pope is Catholic, I can also reverse that. I can make a statement that says, if I have some reason to say this, the Pope is not Catholic. And if I've already said that the Pope is Catholic is symbolized by the letter P, I'll put a squiggle in front of the letter P. The technical name for that squiggle is a tilde. It's on your keyboard at the upper left-hand corner. You can think of it as just a minus sign. If P is the Pope is Catholic, the squiggle indicates, no, that's not true. And so that's now the proposition the Pope is not Catholic. We're going to use the tildes all over the place. And in fact, they're very flexible in their usage. The next thing that we're going to look at are the connectives. We typically work with the letters P and Q, and this is what the 3 connectives look like. We can have a dot, we can have a little V, and we can have an arrow. If for some strange reason you pick up another logic textbook, you might find other symbols being used. When I first learned this, it was represented like this. There was a V that went down, a V that went up, and a V that went to the side. And maybe for some people that was real obvious, but that drove me a little bit crazy because I kept having to look at the V that was down and the V that was up and going, okay, which is which? So I'm trying to come up with something very simple here that's easy to write and that you can remember quite easily. The dot here, we'll just call it the dot for now, represents the word and. So the logical statement P dot Q is P is true and Q is true. This is the easiest one to understand. Now we like to make a little chart here that demonstrates what happens when we have values for P and values for Q. It turns out that there's 4 values that those 2 letters can have. If P can be both true and false, and Q can be both true and false, there's 4 combinations. And the way we're going to do that is T, 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 F, F, T, F, F. You're going to see this a lot, and you will need to memorize this. Once you remember this, Then we need to put down what the values are for and. So I've got two statements, this and that. So P will be equal to, we'll keep the Pope in here for now. And Q, Queen of England, let's say, is named Betty. Okay. Now, if you want to be very fancy about this, we talk about different worlds represented by these. That's kind of an overstatement, but it works. P and Q. So I check the world in which this line 1 is the case. In line 1, P is true, meaning the Pope is indeed Catholic. I go check, and yeah, he's got a good membership card for the Catholic Church. And then I go meet the Queen of England, and I find out indeed her name is Betty. And so that whole statement, the Pope is Catholic and the Queen of England is named Betty, that whole thing is true. We go to World 2. I visit World 2. The Pope is Catholic, but the Queen of England is named Margaret and is confused if I call her Betty. If both parts of this aren't true, the and statement is false. It is false that both the Pope is Catholic and the Queen is named Betty. Okay? I go to World 3. The Pope is in fact not Catholic. He's this robot Pope that I made up earlier. But the Queen is named Betty. Well, it's not true that they're both the case. The Pope is not Catholic, but the Queen's named Betty. So P and Q is false. And I go to World 4, and World 4 is not really recognizable. The Pope is a space alien, and the Queen is named Fred for some really strange reason. Well, we're definitely in bad territory here. So the truth table for P and Q is this, TFFF. Now you'll see a full explanation for this in the book under Chapter 6. I'm just trying to show you what's going on here and talk it through a step at a time. Because the pages that make up this chapter, there's just not a lot of them. There's not a lot of information here. One of the things that is true about this material in Chapter 6, 7, and 8 is it's all very simple. But because it's simple, it can be real easy to misunderstand. So there's our ands. Our next statement is the little v. And this is a symbol for the word or. P or Q. The word or, it turns out, has two separate meanings. You can read in the chapter what those two separate meanings are. In logic, it means one thing in particular. Either P is true or Q is true, and perhaps they're both true. One or the other of these is true. Maybe they're both true. The only thing that I'm saying isn't the case is that they're both false. So if I do this chart again, T, 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 F, F, T, F, F, and I do the statement or, I end up with something that looks like this, T, 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 F. Now, let's say that it's test time. This is probably an easy example for this. And P is going to say that I need to bring a pen to the test. Or, says the teacher, you can bring a pencil. Let's just pretend for now that the letter Q makes some kind of sense if I'm talking about a pencil. So I show up for the test and I bring both my pen and my pencil. And the teacher said to bring either a pen or a pencil. Well, I'm good. I've got something to take the test with. Scenario 2. I have my pen but no pencil. Teacher's happy. I've got something to write with. Scenario 3. Now again, I could talk about these as worlds as well if I wanted to be a bit silly. I forget my pen, but I've got a pencil. Teacher's happy. I've got something to write with. In situation 4, I bring a can of spray paint. I am lacking a pen. I'm also lacking a pencil. That's the only time the teacher is going to get mad. I have failed to bring a pen or a pencil with me. So the or table looks like this, T, 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 F. The and table looked like this, T, F, F, F. They're not the opposite of each other because they both start off with T and end with F. They differ in the middle. By the way, we're only going to do 3 of these connectives. Theoretically, you could have a total of 16 connectives, most of which would serve no particularly good purpose, but these are quite handy. And again, as I show you at the end of the chapter, this is stuff that's actually used in electronics as computers process digital information. The last thing is the arrow, and this is the tricky one. This is an if-then statement. And we don't use a formal if-then very often in language. In fact, one of the biggest challenges when you're doing computer programming is to take things that people say in normal language, like how I would diagnose a problem with a car, and express all of that in a formal logical manner, because people normally don't talk in a formal logical manner. My standard example for this is to say if rain, then clouds. What this means is that if I see rain outside, I know without looking up that there have to be clouds, because only in the presence of clouds do we have rain. Now, that doesn't necessarily mean that if there are clouds, there has to be rain. It just means if there's rain, there have to be clouds. The if-then statement only works in one direction. Another example of this would just be to look at animals. When Aristotle devised his system, he was thinking largely of biology, and so he was trying to organize information about animals. Again, this is not his system. We're not going to be in this book getting into that. I've taught it in the past, but we're not going to be doing that. So if I look at something and I realize it's a cow, I also know then that it must be a mammal, because all cows are mammals. Now, let's say I make this claim, if cow, then mammal. So instead of P's and Q's, let's use C's and W's. T, 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 F, F, T, F, F. If it's a cow, then it is a mammal. Okay, that was good. I look at animal number 1. I check it out, it is a cow. I check it out, it's a mammal. Life is good. Let's cut down to animal number 4. Animal 4 is not a cow. Let's say it's a turtle. And it's not a mammal, it's a reptile. If my statement is, if it's a cow, then it's a mammal, and I hold up a turtle, and that turtle is a reptile, does that shock anybody? Does that frighten anybody? Does that make that false? That's perfectly reasonable. No one's going to have any panic over that. So we're going to call F arrow F true. What if I pick up a bat? And that bat is also a mammal. So C, it's a cow, is false, but M, it's a mammal, is true. I have a bat. A bat is not a cow, but it's still a mammal. Again, nothing perplexing about that. The only thing that would really create a problem is if I have a cow, this is line 2, and it is true that it's a cow, but it's false that it's a mammal. That's the only thing that would cause me to get really weirded out. Because why? Because I have this cow, but for some strange reason it's a bird. How a cow gets to be a bird, what that would even look like, I don't know. I suppose it's a cow with feathers. But if I run into a cow with feathers, I've got a big problem. Something really weird is going on, and my statement, if it's a cow, then it's a mammal, that thing is going to be falling apart. So those are the 3 connectives. And one of the first things you need to just memorize are these 3 charts. TFTT for the arrow, for the or statement, TTTF, and then TFFF for the and statement. We're going to use these symbols through chapters 6 and 7 and 8. So you need to have all of those really comfortably in your head. Particularly at the end of chapter 7 when we're doing short truth tables, you're going to need to know them. Now there's 2 exercises I'm going to give you to do. And one of them is to try to come up with the value of a complex proposition. Now, in the current book, it looks like I'm on about page 117, but there's a chart here. I've got a written description of how all this stuff works, and then a chart for all of it using the letters A and B. And then there's some rules down here about how to put these propositions together. So I'm going to do the whole chart here with A and B the way it is in the book. T, 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 F, F, T, F, F, A and B, A or B, A arrow B. Okay? This is T, F, F, F. This is T, 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 F. This is T, F, T, T. Now, I've already explained it, so I'm not going to try to explain it again. You should, after some practice, be able to just kind of kick out a chart like that. And when you're taking the final, it's good to have that in sort of the margins. Write that down in your margins when you're taking the test. That's a good reference because you're going to use it for a lot of things. So what are the problems? If you look at the problem set that is labeled 6-2, you're going to see problems that look like this. Not A or B or C. And so I'm going to ask you to think about how all this stuff works together. What happens when you put it in sequence? Because if you just have A and B, that's where they all go. TFFF, TTTF, TFTT. But what if I end up with something like this? Is this whole statement true or false? Your first problem is that you don't know what any of these letters stand for. And so for the sake of this one exercise, and this does not apply later on, I want you to say that anytime you see a vowel, it's false, and anytime you see a consonant, it's true. And that's just because I say so. In other problems, that won't be the case because you don't know what this stands for. So what we have here is not false or true or true. Now what you want to do is go inside of parentheses. This will remind you of some of your math homework. Don't be freaked out by that. T or T, just look in the parentheses. True or true. The way you would read that on this chart is that the left hand is true and the right hand is true. So we're in line 1 and the symbol is OR. Here's OR. True or true. And if I match those together, the left, the right, and the connector, I come to right here, and I know that true or true is true. Okay? And the parentheses go away here because I was using them just to hold that together. You have to have parentheses in a problem like this because there's no necessary reason that the A doesn't go with the B or the B doesn't go with the C. You just have to be told. Now I have not false or true. Not false, this is going to really be a challenging thing for everybody, I'm sure. The opposite of false is true. Not false is true. So this thing becomes true. So the whole thing boils down to T or T. We already know what T or T is. T or T is, right over here, true. And so when you have a problem like this, you're going to replace the vowels with falses, the consonants with trues, and by the way, I will skip the letter Y. And then you're going to work out from the inside out and solve for the whole problem. Okay, let's do another one of these because the answers are in the back of the book and I show you stepwise how to get at them, but I want to give you a general picture for what you're going to be doing with this kind of problem. So the next one looks like this. P arrow, Q arrow, U. The vowels are false and the consonants are true. So P becomes T, Q becomes T, and U becomes F because the vowels are false. I go inside the parentheses. T implies F. T's on the left, F's on the right. T implies F, here's T, here's F, and here's the arrow. So they meet up here. And that is false. T arrow F is F. So this thing in parentheses just becomes the false. T arrow F, T arrow F, and I already know what this is. True arrow false is false. And so my answer for this complex proposition is this whole thing is false. So that's what you're going to be doing for problem set 6-2. On the final, you will have some problems like this to work. Okay, so you need to have this chart in your head, and if you need to write it out on the test in the margins, that's fine. I'm going to give you some problems like this, and you're going to turn and the instructions will state that in case you forget what I was doing. Vowels false, consonants true, and then you solve from the inside out. If you're not real sure, again, look in the back of the book because it goes step by step in solving these problems. So that should not pose any huge issues for you. And usually people do pretty well on that part of the test. There's only one other thing we're doing with Chapter 6, and it's pretty easy. The other thing we're doing in Chapter 6 is translation. And this, as I said, is the one time that we're going to be looking at actually how you do this. That is to say, how these symbols are going to relate to the real world. In the version of the book I'm looking at, it's page 120. It's after the section that we just dealt with. And so what are we going to do? We're going to translate some statements here. I start off with a story about Jim and Monique coming to the party. I've got things here about flipping switches. The thing that actually works easiest here is if I imagine I'm trying to take classes. So let's let the letter A be algebra, and B will be biology, and C will be computers, and D will be let's say you're going to take a music class and you're going to play the drums. And those letters stand for what they stand for because I say so. Now, if these are the classes I can take, and I make a statement like A and B, what I'm saying here is I can take both algebra and biology. If I say C or D, that means I can either take computers or drums. And a lot of what happens when you're working on your schedule is you're trying to realize what you can do at the same time you can do something else, and what things are precluded and which classes have prerequisites. It all gets kind of complicated. But this stuff is actually easy for machines to understand because it's simple rules. So what are the rules? The first one, it's letter A in the book, is the word but. If I see the word but, what does the word but mean? Now there's three classic conjunctions, and, but, nor. If you've watched Schoolhouse Rock, you might know a little song about and, but, nor. And is the dot, or is the V. What's the but? Well, if you really think about it, the word but means the same thing as the word and. And I'll show you why. I'm happy and it's Monday. I'm happy, but it's Monday. Now, if I make this statement, I'm happy and it's Monday, is it the case, at least from what I'm saying, that I'm happy? And the answer is yes. Is it Monday? Yes. Okay, that's its logical meaning. This is true and this is true. It's an and statement. If I make a but statement, I'm happy, I am asserting that indeed I am happy. I am also asserting that it's Monday. I'm happy, but it's Monday. But is the same thing as the and. It does the same logical function. But the reason we have a separate word for it in English is that it is and plus a warning. And the warning is that what follows may not make a lot of sense. So if the first thing I have said for you is I'm happy, and I give you the warning, that means that the next thing to follow may not make a whole lot of sense to you. It may seem odd. And I'm warning you that something odd is about to show up. So I'm on fire, but I like it. Okay? I know you don't expect me to say that, and so I give you the warning word of but. If I just say, I'm on fire and I like it, that doesn't quite sound right because I should not enjoy being in flames. But that's just how you put that together. So the word but is and. If you see the word but, you're going to have that as a basic tool. You've got some other combinations to go, and I'll go quickly down the list that you have in the book. If you see the phrase either or, that means exactly the same thing as the word or. It's just either marks the left-hand side. What follows either is on the left-hand side of the or, and what follows the or is on the right-hand side. But it doesn't change anything. It's just represented by that little V. If you've got more than two things going on, A and B or C, there has to be something that tells you whether B and C get put together with parentheses or A and B get put together with parentheses. This is like in math if you have 3 plus 4 times 5 as opposed to 3 plus 4 times 5. Where I put those parentheses changes the meaning. The common tool for all of this is simply going to be the comma. When you see a comma and multiple connectives, that tells you what gets grouped together. And you can look in the examples in the book to see how that works. The arrow thing is a source of a certain amount of confusion. I told you before that this is an if-then statement. If P, then Q. If P, the word if is not symbolized. It's just the left-hand side that you mark with that. Then marks the right-hand side. So if P, then Q, you can think of the arrow as just being the word then. P, then Q, and that P is the arrow. By the way, the arrow always goes to the right. If P, then Q. There is one rather odd thing that happens with this, and this is in letter E. Something that only really shows up in logic, only if. Now, I can't say that I see this out a whole lot outside of logic, but it's a standard logical marker. The word only if, the phrase only if, sounds like the left-hand side, but really what it is the same thing as the right-hand side. So, if I'm snowing, then I'm cold, means the same thing as only if I'm cold is it snowing. And that's not the way people usually talk. But the word only if means the same thing as the word then. So when you see an only if, that's actually an arrow. Whereas if you see the word then, that's the arrow, and if doesn't get symbolized at all. Work the problems in the book to see exactly how that then cashes out. The last little bit of this is the word, well, the words neither nor. It sounds a lot like either or, of course, but it's negated. There's actually two separate ways to do this symbolically. I can say not P and not Q. And why do I do it this way? Neither nor. If I say I'm neither Hungarian nor Anabaptist, I'm saying I am not Hungarian and I am also not Anabaptist. That's false and that's false. The other way to do it is to negate an or statement, and the or statement has to go inside of parentheses. It is not the case that the or statement is true. These, it turns out, mean the same thing. We'll show later how you can prove that. That's something you do in Chapter 7. But for right now, just memorize one of those two. There will, on the final, be several questions related to this translation. So look at the explanation that's offered to you in the textbook at the very end of Chapter 6. Work the problems here with these switches and toggles, and make sure you know how to do that. Again, it's explained stepwise in the back of the book. This whole business about logic gates, these are just symbols that are used to represent them in electronics. That is not testable material. I just throw that in there in kind of a desperate attempt to show you that this stuff actually has application. So, be very, very clear when you're working on this about those original meanings, the ands, the ors, and the if-thens. We're going to use that a lot. And in fact, the only reason that 6 is here, 6 is a short chapter, is to warm you up for what's going to take place in chapters 7 and 8. If you're putting this material off, famous last words, if you're putting this material off to say the week right in front of finals, you have got a lot of work to do because even though these don't take up a lot of space, this is densely packed material, and it takes a while and a lot of practice to get really used to it, to get comfortable with it. So what I would ask you to do is to spend some time on this, to process the information, to work the exercises, and put it down and then try it again. There's not a lot to know here, but every bit of it is critical. So go through Chapter 6 and make sure you completely have this down before we start in on Chapter 7. And with that, I'm going to come to the conclusion of this section. And we'll stop the tape, and then we'll go on and go to the next one. We're going to start in next on first part of chapter 7, which is long truth tables. Thank you.